Hello, Algebra 2 girls. We are starting a new chapter. And this chapter is called Rational Functions, I think. And today we're going to just start to talk about a rational expression. We're not even going to have any equations yet. There's no equal to sign. There's only just an expression, and then we're going to simplify them. We're going to start out slow. So a rational expression, you can follow along. I attached the notes to this assignment and the blank notes. So if you can or want to print them at home and fill them in, you can, or you can just look at them and write on another sheet of paper, whichever you would like to. These are just for you, so whatever makes most sense for you. So a rational expression is a ratio of two polynomial expressions. Okay, and then we have some steps to simplify rational expressions. That's what we're going to talk about today. We're going to simplify. Here's our steps. We're going to factor everything. We're going to simplify the monomials, and we're going to eliminate the common binomial factors. So all of that will make sense once we do some. So let's do some of these examples. Now, I'm going to do an example, and then if you would like to, after I do a couple, you can pause the video and try it yourself, and then see if you get the right answer. Okay, you're going to have to take some responsibility for your own learning here. So, number one, 20x to the 6th over 14x squared. So let's do these steps. Step number one, factor everything. Well, there's nothing to factor here because they're all monomials, so we don't have to do that. Step two, simplify the monomials, and at the top you can see where it says use the exponent rules. So let's think of this as 20 over 14 times x to the 6th over x squared, and think of each part separately. How can we simplify 20 over 14? 2 goes into their 10, 2 goes into their 7. So that becomes 10 over 7. And then this, x to the 6th over x squared, you can, however you like to simplify this, if you want to use exponent rules, you're going to say 6 minus 2 is x to the 4th. Or you can think of it as 1, 2, 3, 4, 5, 6 x's on top and 2 x's on the bottom. Those are going to cancel, and we're left with 4 on the top. Whatever makes most sense to you. But anyway, our answer for number one is 10x to the 4th over 7. All we're doing is simplifying it. We're taking what's there and seeing what we can simplify it down to. So let's look at number two. We're not solving for anything. There's no equal to sign in our equations yet. 6k minus 36 over k minus 6. So let's do step number one, factor. What can we factor in the numerator? We're going to take out a greatest common factor, which is 6, and then we're left with k minus 6. And on the bottom, there's nothing we can factor, k minus 6. So there's no monomials that we need to simplify here. So we're going to eliminate the common binomial factors. We're going to cross these off because they're exactly the same, and our answer is 6. So that's all we're doing right here. Let's look at number 3. Y plus 8 over y squared plus 2y minus 48. Okay, step one, factor everything that can be factored. The numerator is already factored. The denominator, we have to say what multiplies to give you negative 48 and adds to give you positive 2. That's going to be 8 and 6. And the 8 is going to be the positive and the 6 is going to be the negative because we want the 2 to be positive. No monomials to do. We're going to eliminate the binomials that are the same. This was just y plus 8 on the top. And what are we left with? We're left with a 1 over y minus 6. And that is our answer. Okay, because we crossed everything out on the top, we're left with a 1. We're not left with a 0, we're left with a 1. Because we kind of divided by y plus 8. So y plus 8 divided by y plus 8 is 1. So that's our answer. Let's look at number 4. Ooh, this one's going to be tricky. 2r squared minus 2r minus 40 over 8r plus 32. So first of all, let's factor the numerator. We don't want to factor this until we take out the greatest common factor, which is a 2. And we get that. And now we can go ahead and factor that. What multiplies to give you negative 20 and adds to give you negative 1. That's going to be 5 and 4. And the 5 is going to be negative, and the 4 is going to be positive. Now the denominator, what can we take out of 8 and 32? We can take out an 8, and that becomes r plus 4. So we got this. Now I like to kind of do step 2 and step 3 at the same time. I'm going to cancel the r plus 4s. Because they're the same, and I'm going to look at the monomials, which is a 2 on top and an 8 on the bottom, and say 2 goes into there once, 2 goes into there 4 times, so my answer is r minus 5 over 4. Let me write that better. And that's my answer. Okay, let's look at number 5. Now, before I start number 5, I'm going to erase that. Before I start number 5, look at the little thing on the side where it says watch out. Remember that a minus b, or a plus b over a plus b equals 1. A minus b over a minus b equals 1. But a minus b over b minus a equals negative 1. Okay, if they are opposite of each other, then it equals negative 1 instead of positive 1. When you're adding, it doesn't matter if it was a plus b over b plus a. Doesn't make any difference. It always equals 1. But when you're subtracting, if they're opposite of each other, then it equals negative 1. So let's look at number 5. We've got p squared minus 49 over 7 minus p. So p squared minus 49, difference of two perfect squares, which is p, 7, 7, 1 is plus, 1 is minus. You got to think of back on all of our factoring techniques, and then look what we've got on the bottom, 7 minus p. So there's a couple things that you can do. You can look at this and say p minus 7 over 7 minus p equals negative 1. So this equals negative p plus 7, or negative p minus 7 if we distribute that. But I like to do this instead, and whichever one of these makes most sense to you, okay? If I have this, p plus 7 over p minus 7 over 7 minus p, okay? Going right back up to this, I'm going to say, I'm going to switch this 7 minus p around. So it now is p minus 7 so that they match. But if I switch it, I got to put a negative in front of it. I can switch it around if I put a negative in front. So now these can cancel, and I'm left with p plus 7 over negative 1, which is the same thing that we have up here. It can just be negative p minus 7. So whichever one of those makes most sense to you. That might have been too confusing. If you want to use this little thing over here, whatever you want. You just need to know that when they are opposite of each other and it's negative, that you have to make it, you've got to put a negative in there. All right, let's look at number 6. We're getting more complicated. 12a cubed minus 3a over 12a cubed plus 6a squared. All right, what can we factor out of the numerator? Well, we can factor out a 3 and we can factor out an a. And if we do that, then we're left with 4a squared minus 1. And in the denominator, what can we factor out? We can factor out a 6a squared. And if we do that, we're left with 2a plus 1. Okay, are we done with step 1? Will we factor everything? Not quite, because look at this. This right here is a difference of 2 perfect squares. So we have to factor that again. And that is 2a plus 1, 2a minus 1. Because 4a squared is 2a times 2a, and 1 is 1 times 1. And then the denominator is going to stay the same. So let's see what we can cancel. We can cancel those. 3 goes into there once, 3 goes into there 2 times. Here's a to the 1, and a cancels with that, and we're left with 2a minus 1 in the numerator, and 2a, let me put that in the middle, and 2a in the denominator. And that is going to be your answer. Okay, let's look at number 7. Again, remember that if it's going to be helpful to you, go ahead and pause this and try some yourself, and then come back and see if you get the right answer. 6n squared plus 8n plus 2 over 2n squared minus 2. All right, let's start with the numerator. I'm actually going to just put it over here because it's going to take us a little time. Instead of, let's just deal with the numerator. I'm going to first factor out the greatest common factor, which is a 2. So I get this, 3n squared plus 4n plus 1. So we've got to factor this now. Now, you can do guess and check if you want. That's how I would probably do it. But, or you can do this thing, where you take the 3 and put it over there. So you get n squared plus 4n plus 3, and then you would factor that, and you say what multiplies to give you 3 and adds to give you 4. That's going to be 3 and 1, but we multiplied by 3, so now we have to divide by 3, and this becomes n plus 1, 3n plus 1, and we have that 2. It's got to come down 2. We can't just forget about that 2. So the numerator becomes 2 times n plus 1 times 3n plus 1. Okay, we just did that right there. There's what the numerator becomes. The denominator, we can factor out a 2, and we're left with n squared minus 1. Oh, but look at that. This is difference of 2 perfect squares. So we can factor that again. The numerator is all factored. The denominator can be n 1 plus minus, and then we can go ahead and cancel what we can cancel. N plus 1, n plus 1, 2, 2, And our answer is 3n plus 1 over n minus 1. And that's our answer for number 7. All right, let's look at number 8. 45 minus 5w over 3w squared minus 28w plus 9. So what can we do here? Well, we're going to have to factor, the top is going to be okay. We can just factor out a 5. But let's look at the denominator. I'm going to set it over here again and decide how I'm going to factor that. You can do guess and check, or you can do this, and it becomes w squared minus 28w plus 27. And what multiplies to give you 27 and adds to give you negative 28. That's going to be negative 27 and negative 1. But we multiplied by 3, so we have to divide by 3. And this becomes w minus 9 and 3w minus 1. So back to our original problem. The denominator becomes w minus 9, 3w minus 1. And the numerator, we can factor a 5 out of, and we get 9 minus w. So what can we cancel? Can we cancel 9 minus w and w minus 9? Only if we put a negative out in front. We can cancel those if we put a negative somewhere. So I'm going to do that, and I'll get negative 5 over 3w minus 1. And that's my answer for number 8. Okay, simplifying rational expressions. That's what we did right there, 3 steps. Now let's look at the next page. Multiplying rational expressions. If the problem contains monomials only, then you're just going to multiply them and simplify what we just like what we did. If the problem contains binomials or trinomials, you're going to factor everything first and then simplify. So this will make sense once we try some of this. Number 9, 6x squared y cubed, right, times 10x cubed y to the 4th over 2x squared y squared times 18y squared. All right, this is like the one at the top where it says monomials only. There's no addition or subtraction or anything. Everything's just here. We're just going to multiply everything together and then simplify. So in the top, we're going to do 6 times 10 is 60. X squared times x cubed is x to the 5th. X cubed times x to the 4th, or y cubed times y to the 4th is y to the 7th. In the denominator, 18 times 2 is 36. X squared, y to the 4th. And then we can just go ahead and cancel things. What goes into 60 and 36? 12 goes into 60 5 times. 12 goes into 36 3 times. What are we going to do with our x's right here? We have 5 on the top and 2 on the bottom. All of the ones on the bottom will cancel, and this becomes a 3. Here we have a 7 minus 4, so that becomes a 3. So our answer is 5x cubed y cubed over 3. And that's our answer for number 9. Number 10 is the same type of problem, just monomials. 4a squared b squared over 15ab squared, ab cubed. All right. And then we got 5a cubed b to the 6th over 12a to the 4th b to the 7th. So we're going to put everything together. 5 times 4 is 20. a to the 5th, b to the 8th. And in the denominator, 15 times 12 is 180. A to the 5th, b to the 10th. 7 plus 3 is 10. Remember, when you're multiplying, you add exponents. Now, what can we cancel? What goes into 20 and 180? 20 goes into there once. 20 goes into there 9 times. Look at this. All the a's cancel. A to the 5th over a to the 5th. And now we have 8 b's on top and 10 on the bottom. So all of those go away, and we're left with 2 in the denominator. So look, everything in the numerator canceled, which means we have a 1 and we have a 9b squared left in the denominator. And that's our answer for number 10. Number 11, now we don't just have monomials anymore. We have binomials and trinomials. So we're going to take 4. I think these are easier than the monomials. I don't know, easier, but things cancel nicer sometimes. You don't end up with such big numbers. All right, so now we are not going to multiply straight across, because that wouldn't be any fun to have to multiply this times this. We're going to factor everything just how it is, okay? So 4x squared minus 4x, we can take a 4x out of, and we're left with x minus 1. That's how that goes. In the denominator here, I'm going to put it over here, 2x squared plus 4x minus 6. I'm going to factor out a 2. And then I'm going to say what multiplies to give me -3 and adds to give me +2, and I get that. So this denominator becomes 2 times x plus 3, x minus 1. And this one up here, what multiplies to give you -6 and adds to give you 1, that's going to be a 3 and a 2, and the 3 is going to be positive, and the 2 is going to be negative. And down here, I can factor out a 4x, and I'm left with x plus 2. And now we can see what it is we can cancel, okay? Well, we can cancel this 4x and this 4x. You can cancel now anything that is in this whole numerator with anything that is in this whole denominator. Everything is over everything now. So we got an x minus 1 and an x minus 1. We've got an x plus 3 and an x plus 3. Can we cancel x minus 2 and x plus 2? No, we can't. So we're left with x minus 2 in the numerator and 2 times x plus 2 in the denominator. And that's the answer. That's as much as you can do. Okay, let's look at number 11, or 12. That was number 11. Number 12, 10v minus 5v squared over v squared minus 11v plus 18 times v squared minus 8v minus 9 over 15. So let's see what we can factor each part. This 10v minus 5v squared, we can take a 5v out of, and we're left with 2 minus v. The denominator here, what multiplies to give you 18 and adds to give you -11, that's going to be 9 and 2, and they're both going to be negative. Right up here, what multiplies to give you -9 and adds to give you -8, that's going to be a 9 and a 1, and the 9 is going to be negative, and the 1 is going to be positive, and we've got a 15 on the bottom. Can't do anything with that. So now let's start crossing stuff off. V minus 9, V minus 9. 5 goes into there once, 5 goes into 15 3 times. Now what about this right here? 2 minus V and V minus 2. Can we cancel those? we can cancel them as long as we stick a negative out in front. So now we are left with negative v plus 1 in the numerator. We got a negative 1 right here times v plus 1 right here. And in the denominator, we have a 3. So you can write it like this, or you can distribute that negative and write it like this. It's the same thing, whichever way you like. Okay, that is how you multiply. Now let's talk about dividing. To divide rational expressions, you're going to multiply by the reciprocal of what you are dividing by. Okay, so and then you're going to do it exactly the same as we did the multiplication, because you're going to just flip one of them, you're going to flip the second one, and then do it like we've been doing. So 13, 5pq over 16p cubed divided by 35p squared q squared over 8q to the 5th. So we are going to write the first one exactly like it is, and then we're going to change the division to multiplication, and we're going to flip the second one. Take the reciprocal and then solve it just like we solved it up above, because now it's just a multiplication problem. So we're going to say 5 times 8 is 40, p q to the 6th, because q times q to the 5th is q to the 6th. And in the denominator, 16 times 35 is 560, p to the 5th, because we have p cubed and p squared, q squared. And now we can just go ahead and cross things off. Okay, 40 actually goes into 560 14 times. Who knew? And we got 1p here and 5 down here, so that's going to all cancel, and that's going to become a 4. We got 6 q's up here and 2 down here, so those are all going to cancel, and that's going to become a 4. And we are left with q to the 4th. Oh, sorry about that. Q to the 4th over 14p to the 4th. And that is our answer for number 13. Okay, let's look at number 14. Same thing. Reason we're putting these together is because all you do is flip one and then you solve it the exact same way that we just solved the multiplication. So we've got 10 over 4x minus 8 divided by 2x squared plus 6x over x squared plus x minus 6. So we're going to write the first one exactly like it is. We're going to change the division to multiplication, and we're going to flip the second one. You have to flip the second one. You can't flip the first one. And now solve it like we've been doing. Let's go ahead and factor everything. We're not going to multiply straight across because we have trinomials and binomials. So the 10 is going to stay. And on the bottom here, we're going to take out a 4, and we're going to get x minus 2. And then this one, we're going to say what multiplies to give you negative 6 and adds to give you 1. That's that. And down here, we're going to take out a 2x, and we're left with x plus 3. And let's see what we can cancel. We can cancel x minus 2 and x minus 2. We can cancel x plus 3 and x plus 3. And what can we cancel here? We can say 2 goes into there once, 2 goes into there 5. And we're left with a 5 in the numerator and a 4x in the denominator. And that's our answer for number 14. Okay, 2 more. Number 15. Okay. Number 15. 2a cubed minus 12a squared over a squared minus 4a minus 12 times 24a squared minus 8a cubed over, oh no, divided by a squared minus 8a plus 15. So the first thing we're going to do is write the first one exactly like it is. And we're going to change it to a multiplication and take the reciprocal of the second one. Now we're going to factor everything we can. Right here for this one, we can take out a 2a squared, and we're left with a minus 6. Down in the denominator, we're going to say what multiplies to give us negative 12 and adds to give us negative 4. And that's going to be a 6 and a 2. And that one's going to be negative and this one positive. Up here, what multiplies to give us 15 and adds to give us negative 8. That's going to be a 5 and a 3, and they're both negative. And down here, we can take out an 8a squared, and we're left with 3 minus a. And let's see what we can cancel. We can cancel a minus 6 and a minus 6. We can cancel 2 goes into there once, and 2 goes into 8 4 times. We can cancel the a squareds. And then we've got an a minus 3 and a 3 minus a. Can we cancel those? Only if we put a negative out in front. So we're left with negative a minus 5 over 4 times a plus 2. That's what we're left with. In the denominator, we've got a plus 2 and we've got a 4. And in the numerator, we've got an a minus 5 and a negative 1. So, and if you want to simplify that a little bit, you could distribute the negative and say negative a plus 5 over 4 times a plus 2. It becomes plus 5 because the negative goes there and there. And that's your answer. So one more, number 16. We've got k plus 3 over k divided by 4k plus 1 times 16k squared minus 1 over k plus 3. Whoa, that one is complicated. So since the dividing is right here, we are going to just take the reciprocal of this one. We're going to change it to addition, multiplication. So to take the reciprocal, I'm going to think of it like this. So I'm going to rewrite it as k plus 3 over k times 1 over 4k plus 1 times 16k squared minus 1 over k plus 3. So this is the only one that we needed to take the reciprocal of. Now let's go ahead and see if there's anything we can factor. Well, k plus 3 over k is all factored, and 1 over 4k plus 1 is already factored. But this one is a difference of two perfect squares. It's 4k, 4k, 1, 1, plus, minus, and k plus 3. So then we can go ahead and cross off what we can. 4k plus 1, 4k plus 1. What are we left with? 4k minus 1 over k. And that is your answer to the last one. All right, I'm going to attach the homework for you, and I will tell you what you need to do for the homework. But this is our first section lesson for our new chapter.